Hello friends, in this video I am going to do calculations for kinematic indeterminacy. We will find kinematic indeterminacy of two-dimensional structures. This is the formula: kinematic determinacy equals to total freedom minus m, where m is their total members, or you can say it is equal to axial deformation. We are subtracting from degree of freedom because we want to ignore this axial deformation. It is very small axial deformation, so we always prefer to ignore it. Let us start from simple example. Now this is a fixed support, so degree of freedom for this is 0, and this is there is not any support, so there is degree of freedom 3, because there is no reaction, there is all degrees of freedom in every direction, so this is 3. So kinematic determinacy equals to degree of freedom, total degree of freedom, that is 0 plus 3, that is 3, minus m, where m is number of members, m is 1, here it is 1 member, minus 1, that is 2. So this is second degree kinematic indeterminate structure. Now let us start now this another example. This is a hinged support, so freedom for this support is 1, and this is a roller support, so degree of freedom for this support is 2. So kinematic determinacy equals to total degree of freedom, that is 2 plus 1, that is 3, minus members, total members, here it is 1 member, so it is equal to 2. Like that, if we start other example. This is a fixed support, so kinematic degree of freedom for this is 0, and you have to remember degree of freedom for hinge is always equal to 4. This is also a hinged support, so degree of freedom for this is 1. This is all another hinge, so degree of freedom for this is 4. This is a roller support, so degree of freedom for roller is 2, and here is no any support, so all are degrees of freedom, so degrees of freedom is 3. So kinematic determinacy equals to total degrees of freedom, that is 4 plus, that is 8, 9, 10, 11, 12, 13, 14, that is 14, minus total number of these members, here it is 1 member, 2, 3, 4, 5, minus 5, that is 9, because between any hinge and any support it is member, or between any two supports it is member, structural member. Now let us take another example. Now this is a fixed support, so degree of freedom for this is 0. This is also a fixed support, so degree of freedom is 0, and this there is not any support, so degree of freedom all are it is free in every direction here, so degree of freedom is 3, and here is not again any support, so degree of freedom is 3. So kinematic determinacy equals to degree of freedom, that is 3 plus 3, that is 6, minus total members 1, 2 and 3, which equals to 3. Now let us take another example. This is a hinge support, so degree of freedom is 1 for this. This is a roller support, so for this degree of freedom is 2. Here it is not any support, so degree of freedom is 3. Here again there is no support, so degree of freedom is 3. Here again at this point there is no any support, so degree of freedom is 3. So total kinematic determinacy equals to total degree of freedom, that is 3, 6, 9 and 12. 12 minus members here, 1, 2, 3 and 4 members, that is 8. Now let us see another example. This is fixed support, so degree of freedom for this is 0. This is hinged, degree of freedom is 1. Fixed degree of freedom is 0. Hinged degree of freedom is 1. And this is roller, degree of freedom is 2. Here at this point there is no support, so degree of freedom is 3. At this point again no support, so degree of freedom 3. So at this point also there is no support, sorry, this is support, degree of freedom for this is 1. So total kinematic determinacy equal to total degree of freedom, that is 3 and 3, 6, 7, 8, 9, 10. 10 minus total members, here it is 1, 2, 3, 4, 5 and 6 members, minus 6, that is 4. So degree of freedom is 4. It is very easy, you have not remember any formula. Hope you have understood this. Thanks.